All right, welcome back to the Face-to-Face podcast. I'm Mark.
I'm Jerry.
I'm Teddy.
Today we have a very special guest. Dr. Deken is a Burroughs teacher and an expert in neuroscience. He has taught classes like bioethics, behavioral neuroscience, chemistry, biology, and more. He's also a head baseball coach for our beloved Burroughs baseball team. Dr. Deken, it is great to have you here.
It's great to be here. Thanks for inviting me.
Of course, and not to mention Dr. Deken is also our friend Carter's dad, and so we already know him a little bit, so it's going to be a fun conversation.
Yeah. I've known Jerry for a long time.
Yeah.
The wee little tot. Yeah.
Yes.
Since how old were you? Like 4? When did you join?
Did you guys go to Forsyth together?
Forsyth, yeah.
Yeah.
Pre-K or junior K or something like that.
Mm-hmm.
But yeah, I guess so. As teenagers, we have like a lot of things that we're interested in, whether that's like, more on the med side of like the neuroscience-y stuff, or also just like on the more fun side of like, the more fun side of stuff. And so we kind of wanted to have like different conversations and kind of learn about that and then talk about it. And, obviously you know a lot about it. And so we thought it'd be really insightful to invite you.
Yeah. Neuroscience is a fun, interesting topic because we're still learning about a lot about the brain. And so that to me is what makes the field so interesting. Is, I think there's still a lot to learn, of course, about the heart and other organ systems, but the nervous system is so complex that we're still in the infancy of understanding what the brain does and how it works.
Yeah.
Could you tell me a little bit about your background with neuroscience?
Sure. So went to college thinking I wanted to be a physical therapist or an athletic trainer or something like that. But took like my biology and chemistry classes, and I was really blown away. My high school wasn't very good. My background wasn't very good. And so, taking those classes was like, oh my God, this stuff's actually really cool, and I actually like learning. And so I switched to become a biology and chemistry major, so double majored in both. And I thought I wanted to be a chemist. So over the summers, I would work for the school, for one of my professors who had a little adjunct thing with Los Alamos National Laboratories. So I did some side work over the summer with him, and I was like, okay, I want to be an organic chemist. And then one of my advisor asked me, have you ever thought about neuroscience? And like, no, not really. And around that time, my grandfather developed Parkinson's disease. And so seeing what he was going through and sort of his decline made me even more interested in like what's going on in the brain. I'd always sort of been interested, like how drugs work and things like that. And so I'm like, no, I'll check that out. Started looking into it and like, yeah, that's actually really cool. And so then I applied to both some chemistry graduate schools, and then I started applying to neuroscience graduate schools. And, it just became more and more fascinating to me. And so I actually finished a baseball game and had an interview the next day at Alabama-Birmingham. So we drove straight, me and my dad drove straight from the baseball game all the way to Alabama. And I was just blown away. I thought it was super cool seeing the labs and all of that stuff. I was sold. The faculty there was pretty young, vibrant. So it just seemed like a place I wanted to go. And so that's where I ended up. Loved my time in Birmingham at UAB. Super intellectually fulfilling. Got to, have lunch and stuff with some of the best scientists in the world because you'd invite people to come in. And so I'm like, I want to be a neuroscientist. But along the way, my professor was like one of the best like lecturers. And he was such a good teacher that it kind of sparked my interest in teaching. So I went to him one day and I was like, do you mind if I teach on the side? And he said, sure, as long as you're doing all your work. And so I taught at 2 local universities in Birmingham, one called Samford University with an M, not the STAN. And so I taught a human biology class there and fell in love with teaching. And then I also taught at Birmingham Southern, which just recently closed its doors, unfortunately, because it was a really cool school. And taught in a genetics course there, and again, loved it. So when I was looking to do my postdoctoral work, part of my stipulation for joining a lab was I get to teach on the side. And my person that I worked for there, Mike Nonay, said that was fine. And so I taught at the University College, which is the night school at WashU. There I taught what was called current issues in medicine, which is essentially a bioethics class. So I team taught that for 2 years. Loved that part of it, with the ultimate goal of like teaching at a high academic sort of smaller school, whereas mostly teaching is some research. But then my joke is, if I didn't know that if you married somebody from St. Louis that you had to stay in St. Louis the rest of your life. And so my wife sent me this, the Burroughs, job posting, and it was already like a week after the post, like the deadline. And so I'm like, well, I'll just try it anyway. So I emailed the then head of school, Keith Shahan, and said, is this job still open? And he said, yes, but I need to call you right now. And so he called me, and we talked for a little bit, and he told me I was actually going to offer this job to somebody in an hour. It was on my to-do list, but we'll wait if you're serious. I said, yeah, I think I'm serious. He's like, well, can you come in right now? I said, no, because I'm in the middle of the experiment. I didn't want to botch that experiment. I said, I'll come in the next day. And so I came in the next day. I taught aim high to sixth graders, taught them how to use a microscope. And they offered me the job that day to join Burroughs. So I told him he had to give me the weekend at least. But I thought it was pretty cool because when I was walking around, Fred Bird was in the hall. And so I love the Cardinals. There's Fred Bird.
Yeah.
And so yeah, I thought about it and took a huge pay cut. And here I am 20 years later. Love it.
Nice.
So a long answer to a short question. So.
Right. So I personally do a lot of meditation, and I hear the phrase or the word neuroplasticity a lot. I'm sure you're familiar with what that is. And could you go a little more in depth on what neuroplasticity is and how we can sort of access the energy in our brain?
Could you also give like a basic definition for those of us who
Sure.
are meditation experts?
Well, neuroplasticity itself is, so the brain is plastic, right? So it can be changed, right? So plasticity is the molding of something, right? So of course, neuroplasticity is how the brain molds itself around experiences, right? Things like that.
So is that more like physical, like actual molding, or like
physical? Yeah. So your brain actually changes.
So the physical structure actually changes.
Yeah.
Okay.
Yeah. So in the short term, what we know is, so there's a short-term process and a long-term process to memory, right? And so memory is all about the plasticity of the brain, how your brain changes, right, with experience or whatever. So in the short term, you have neurons that communicate with one another across the space, right? So you have one neuron talking to another neuron, and there's a gap in between those two neurons. And you're releasing something called neurotransmitter, little chemicals that are being released from the sending neuron that is touching receptors on the receiving neuron, right? And so what happens in short-term plasticity or short-term memory is this connection is stronger, right? So you may release more neurotransmitter, you have more receptors down here. Eventually, with more and more repetition, right? So when you're studying for something, you're doing a lot of repetition, trying to bring up that memory over and over and over again. And so as you do that, you sort of get full, right? So I have plenty of receptors here, but the neurons are knowing this connection needs to be even stronger than it is now with even just more receptors and stuff. And so it starts sprouting new branches, new connections with one another. And that's the basis of long-term memory. And so your brain physically changes these two neurons, or this neuron circuit becomes stronger by having more connections with one another, right? And so anytime you're learning something, that process is happening, and that's the plastic part. And so, for example, if somebody were to go blind or something like that, right? Other senses are enhanced. And the thought there is that you have regions in your brain that are devoted to sight. And so, like areas for hearing will now invade that spots, right? And take over those parts of the brain, right? Because those aren't being used and these are being enhanced, right? Because now sound is even more important to you, right? As a sensory input. And so your brain is changing, right? Sort of that use it or lose it principle. And so you don't use it, those connections actually wither away, right? And the connections that you do use get stronger and stronger.
I think this is kind of reminding me of like a pretty big question that I think a lot of people have thought about for a long time. And it's on the paper here, but I'm really curious. Like, there's a lot of people that are saying like, intelligence, it can't be measured, or like IQ or like EQ, like this is the way to measure intelligence or whatever. So with like a neuroscience background, and like you're actually able to kind of see brains or like see how they work or like how they develop or whatever. Is there a different way that you kind of look at that, a different perspective?
As far as intelligence,
like how it's measured, or
think about intelligence.
Yeah.
Well, one thing is, the IQ test is a flawed test, of course, right? So it's biased by the people who thinks what is intelligence, right?
Why is it biased? I'm not trying to attack you. I'm just curious.
It's it's in the eyes of the beholder, right? What intelligence is, right? So to maybe us, a cockroach might not be that intelligent, right? But cockroach has been around a lot longer than us, so
they can do.
Who's to say they can do a lot of things that we can't? Yeah. So what's smart to a cockroach might be dumb to us, right? And what's smart for us might be dumb to a cockroach, right? And you can think about that, so intelligence really is, I think, the ability to adapt to circumstances, right? For us as humans, we like to think of it as the ability to reason, right? And think through problems and things like that, right? So we have something like theory of mind where we can put ourselves in the minds of others, right? And think about how others might respond, right? We have the ability of language, and so we can pass on our intelligence just with a piece of paper. We don't even talk to each other, right? And so, we've been the beneficiaries of tons of accumulated knowledge, right? So, we're not necessarily smarter than our ancestors who may live 10,000 years ago, right? We just have have this incredible, buildup of accumulated knowledge at our hands, right? We have the internet. We can look at anything now, right? That they couldn't do before, right? So I wouldn't say, we're not any really more intelligent than we have. And it really does depend on how you define intelligence and who's doing the defining. IQ tests of the past would be kind of laughable, right? The original stuff that they were using, and there's partly eugenics behind that and things like that, right? Where we're trying to promote one race over the other, right? And giving people unfair advantages and things like that.
That's not fair, but that's not fair.
Mark, in ninth grade, we were in biology together.
I was obsessed with have you heard the book The Bell Curve?
He was like, I read this really thick book, and it's called The Bell Curve. Everybody should read it. It's so good.
We talked about it
like
every
whatever.
single day in biology class.
It was just
Did you actually
extremely
read it? Did you actually read it?
I still don't believe you actually read it. Like, I'm gonna be honest, it's this huge book.
I got to admit, I've never read it.
And this little ninth grade Mark was like,
chapter.
I love the bell curve. On page 105, they talk about this.
It was just an interesting book because it opened up like a new perspective. Like it's obviously like a hostile perspective, but it gives. I don't know. It's interesting.
No,
it's
it
brave,
plays with interesting ideas for sure.
Right. Can we talk about drugs now?
Sure.
Are you- All right.
So have you done any like research with like LSD and mushrooms? Things of that sort?
I have not. No.
Have
So
you?
I've heard it
Mark?
has like
Have you?
I
Any
know.
first-hand research? Or?
I'm gonna do my research soon, when I get to California. So I've heard it has like there's substances that we think are pretty harmful. That have there's some new research that sort of evidences that these substances can help with like mental health disorders,
Sure.
PTSD, and
Were-
stress.
Were you the researcher? I'm just wondering.
I'm not just conjuring up this info, bro. And so, what are your thoughts about that? Do you think we should bring back these like tier 1 drugs and and sort of
Like medical
and
cannabis?
sort of
I am
try
curious
to
about
develop
marijuana.
it into and do more research for medical use?
Yeah, I mean that's a really interesting topic right now that is going on.
Is that not just super similar to like anesthesia and like stuff like that?
Nah, bro.
Well,
you
I
take
mean-
that crap, you tripping, bro.
Wait, what's
It's
the
different.
what's the one? They put me when I broke my leg when I was 3 years old on some
Yeah.
drug that like just made me lose my memory afterwards, right? So when they like set my leg,
Mhm.
my parents tell me that they remember me like screaming and crying or whatever
Sure.
and like feeling all the pain, but
Yeah.
afterwards I just didn't remember it.
Yeah.
Like
That's pretty crazy.
Yeah.
like
that's, like,
that's
hard
like
to process.
similar, right? It's just like a drug that's
I
used.
don't think LSD
Sure,
and
it's
mushrooms
modifying-
necessarily-
It's modifying the way your brain works,
Right.
right? That's what anesthesia is doing. That's what cocaine is doing. That's what LSD is doing. That's what
Yeah.
opioids are doing, right?
Anything else you're doing? Is
wait, let me see.
So LSD is interesting because it sort of is making a comeback for therapeutic sort of uses,
Right.
which I think is super interesting. So I was it a podcast somewhere that I was listening to, I think, or something I read. They were talking about CEOs. Lots of CEOs are going to clinics and having LSD trips and things like that in order to become more empathetic. So it can unlock parts of your brain.
Have you heard of the
that can
phrase
actually
ego
help.
death?
Uh,
So, a lot of people take LSD. Not me. Not me. I'm just saying.
That's why you're more like empathetic recently. Like,
He
It's
has
like-
been extra empathetic recently.
It's like it gets rid of your sense of self when you trip,
yeah.
and that's what makes you more empathetic and more like reasonable.
Yeah.
You sort of
would not be the same as this mark now. Like,
shut up, shut up. Bro. But no, I just think it's super interesting
is.
that people are having these experiences. Like a lot of people, and like it just completely changes their life. They
Yeah.
become more humble, more empathetic. They have better relationships. It's just like it's quite interesting. But there's also a negative side to it,
Yeah.
which is like, people are there's obviously addictive component to that.
so is it like it's like changing the makeup of their brain, or is it like giving them a perspective without?
It's changing the makeup of the brain.
Right.
So it's like literally
your restructuring is such a powerful experience. For some people, it can be really, really harmful, right? So it can change their way and change their brain in a very, very negative way. So it takes them to darker places.
Like that
Right.
seems like super volatile.
It's a super volatile time, right?
Right.
And that window. That's why it's important to be sort of in a clinical setting. Is that you have to take advantage of that time that
Mhm.
you're in there to restructure in a positive way. And so, for some people, it can go badly, right? And that's where a lot of the research is. How do we manipulate this, right?
And how do we
make
sort of-
it
right.
positive
Mhm.
for whoever needs it? And that's super interesting, right? Super interesting. And you think about cannabis and what we know about PTSD, right? One of the things that's happening is you're trying to restructure your brain around that traumatic event, right? And try to forget that traumatic event through that restructuring, through that plasticity that we were talking about, right? And that's really what behavioral psychologists are trying to do too, is sort of reframe your tragedies in your past, right? So you can think about and build new connections around that reframing. That's why professionals are so important, because they're guiding the reframing, right, in positive ways.
And that would mean it's more dangerous for youth, right? Because it's more
Well, the thing about adolescence is adolescence is a time when your brain is restructuring really, really quickly, right? And so work done by Jay Geet and others, like in the 90s, were the first to sort of see that adolescence is a time of dramatic brain changes. There's something called pruning. So whenever we're born, we actually have way more synapses than any time in our life. And we're just building synapses because any experience might be important. So lay it down, right? Let's just make sure that we have everything that we might need. But you realize you don't need all those synapses, right? And that can muddle the brain. And so what you start to do in adolescence is getting rid of synapses that you're not using, right? So if you're not using it, it's called a pruning process. So you're taking away synapses like you would prune a bush, right, to make the whole tree healthier. You're pruning your brain, taking away synapses to make your brain happier. One of the things that happens in autism is you have way too many synapses. The pruning process doesn't seem to be too complete, and so things can get muddled, right? And like schizophrenia, you have too many synapses being pruned, and so there's a happy medium that has to happen during adolescence, and that's why they think that a lot of personality disorders and things like that, schizophrenia, usually begin in adolescence, and it might be around that, what's happening, all those big changes happening in the brain. So it's a delicate time. But it also means that whatever you're doing during adolescence becomes extra important, right? That if you're trying to learn something new, your brain is more plastic, right? And so you're able to learn a new language, right? Much, much better, right? Maybe not as well as whenever you're 6, and sort of your language window is at its peak, but still your brain is, if you're not using it, you're losing it, right? And if you are using it, you can build those synapses a little bit easier than my 49-year-old brain can do, right? And so, yeah, it is. Yeah. So the answer to your question is yes, right? Yeah. Anything you're doing during adolescence, drugs or learning a new sport or learning to play the guitar, or whatever it is, all that stuff is important to your brain, right?
Mm-hmm. So like if you could I don't know, what is it? Is there any possibility to ever physically go into someone's brain, add more, take away more synapses, or is that not really
That's what teachers do all the time. We're trying to add synapses, right? So
But
we're trying to build those connections.
with someone with autism that has too many? Could you
Yeah.
Is that what a
That's good
lobotomy
question.
is?
Yeah, that's what I was thinking. I watched Shutter Island recently,
Oh,
and they were talking about lobotomies and how that was super unethical and things like that.
yeah. So that's another example where science changes, right? So we now know lobotomies.
So you cut your
It's
brain
they
in half.
go into your brain and actually cut out
So
stuff.
the way
It's
they used to do it, there's a book
to fix you.
by Sam Keen called The Ice Pick Surgeon, where there's a guy that would take an ice pick, a literal ice pick, and you could move your eyeball over to the side and you just crack the back of your orbital bone and you just scramble that part of your brain.
Why is he doing that?
So he's doing it for mentally ill patients. Right?
Did he-
So whenever we didn't know a whole lot about mental illness.
Right.
did it ever work?
And so it would work. It would make people way more calm. But it would also, mainly because their
They can't
prefrontal
really
cortex was
function. They
broken,
can't really
right?
do
And so
anything.
essentially they just wouldn't do anything. They just
Yeah.
became like walking vegetables, right?
Oh, okay.
And so it became way more easy to care for them, right? So mental institution, people who were in charge were like, these people are so hard to care for. Let's give some lobotomies, and now they're just lying in bed all the time. That's a lot easier, right? Is it ethical? Absolutely not, right? And so people caught on that this is not a good practice. And so yes, you can physically disrupt, right, by huge wholesale things.
But
But getting
don't
to
know how.
the specifics of why why the PTSD, right, is happening. Don't think we can rewire that specific circuit because we don't know about that circuit, right? You're dealing with 86 billion neurons, right? With about 1,000 connections each, right? The complexity is staggering.
So with like hallucinations and stuff, is that just like a part of your brain turning off? Because a couple of weeks ago, or a month or two ago maybe, I had like a really high fever. I had like a 103.5 or something.
Hey.
And I woke up in the middle of the night and I like was super confused. I didn't know where I was. I didn't know what was going on. I didn't know my name. I like couldn't speak. And I was like walking around for like a couple minutes and I was like super like toddler. Like I was super like dumb almost. And then I was like fine. But and also the other thing that I remember is everything looked really like zoomed out, right? Like I don't even know how to describe it, but like a 0.5 on like your iPhone, that's what it looked like.
Some LSD, bro.
I was fine. We hadn't even went to the emergency room, but like I was fine. It was just a really high fever. But like, is that just like parts of your brain just like not being able to connect at that moment in time?
Or certain parts of your brain get turned on, right? And so there's a famous neurosurgeon, Walter Penfield, who did a lot of mapping of the brain. So he is an epilepsy doctor. So whenever you have brain surgery, usually you're awake. And so what he would do is whenever he had their skull exposed,
Wait, you're awake?
you're awake, because it'd be really, really dangerous for you to be asleep during brain surgery.
Wow.
And your brain doesn't actually have any pain receptors, right? So you don't feel any pain whenever they're poking around in your brain.
So you're conscious of what's going on.
So they'll give you anesthetics, numb your skull, and then.
So wait,
So
I'm like right here. So
I'm like
just,
lying. I'm
poking
looking
with
at the
my
light
brain.
at the ceiling, and I just see people with like scalpels, just like doing whatever.
Can you like think?
Yeah.
But would it not like mess
That's
up your
crazy,
thinking
bro.
because they're like literally like touching your?
So yeah, that's what Walter Penfield would do. So it was in the 60s, and so he was an epilepsy doctor, and we knew by that time that the brain was mostly communicating through electrical impulses, and so you could add a bit of electricity to different parts of the brain, and it would make you feel things. So he mapped something called the somatosensory cortex, which has a map of your body for all of your sensations. So if you're touched in your finger, right, there's a part in your somatosensory cortex that communication goes all the way up to the somatosensory cortex and says, somebody's touching my finger, or my finger is being touched, right? Same with your leg or wherever, right? It's a whole map of your body. And so what he would do, so he mapped that by adding a little bit of electricity. So he'd zap part of your brain. So somebody would say, "Oh my God, I feel like somebody's touching my finger."
So
right?
who like
nobody is.
Who like was like, yeah, you can do that to me. Like
I think there was enough people, right?
Really?
And so he could zap different areas, right? So there's a region in your brain, the Broca's area, which is responsible for speech production. And so you could zap that part and people just start talking,
Blabbering,
right? Just blabbering, right?
that's like,
But he could also, to get back to your hallucinations, he could zap parts of your brain and people would start to hallucinate, right? And so that brain area starts to become more active. He could give people deja vu experiences and things like that, or out-of-body experiences even, by zapping parts of the brain. So it's a brain thing.
So could you do that without like ripping open someone's skull? Like
Yes.
No, I've had some hallucinations while meditating.
Yeah. So you get
No,
really?
just meditating. Just meditating.
While meditating.
So newer advances, there's something called the transcranial magnetic stimulation, where you can use magnets. So magnetism and electricity are related, as you guys know from physics,
It is.
right?
Not yet.
No,
We don't know yet.
All right.
But
Well, maybe you'll know someday. But essentially, you can focus powerful magnetic pulses into different parts of the brain, and you can control how deep they go and which brain area, and you can change the electrical. You can increase the electrical activity of the brain in that region or decrease it, and so you can do what Penfield was doing, by using magnets, and you don't have to cut anybody's skull open. So
Really?
it's increasingly being used for depression. Right? So,
Yeah, so like make people happy.
yeah, so you're activating sort of those networks that we know are involved in depression, right? Tuning those down, other regions tuning up, right?
So
And
you
people
just
go through.
Tune them down, and it just like stays that way.
Yeah, so it depends on the person, of course, and I'm not the expert here. And so, but it seems to work for a lot of people where you might have to go in for different sessions, right? So I get my weekly tune-up with transcranial magnetic stimulation,
It's really
right, where I
cool.
go in for a 20-minute session of pulsing, right, and then I feel way better. And then
Really.
Is this some new technology? Is relatively
it's
new?
fairly new, yeah. There are places in St. Louis
Really?
where there's TMS centers, right? Actually, a former Burroughs student, his dad worked in the TMS lab. So yeah, it's around and pretty powerful.
Do people like abuse it to make themselves super happy all the time? Like I feel like
It sounds like a
why-
happiness hack. Like
why wouldn't people?
Because you're not there's no addiction. I mean, you could be addicted to it, but there's no like cost to that addiction.
Definitely.
Isn't that what
be
like
addicted
drugs
to it,
do?
right?
Like some drugs, like you're just
Yeah.
happy, so you just keep using it to be happy.
No,
So
but
we
like
actually-
the drugs, like it.
Just talked about this
LSD.
in our bioethics class, where we talked about neuroaugmentation, and so like Neuralink and things like that, Elon Musk's company and all these other companies are coming up, and some of them are about transcranial magnetic stimulation, where you could wear a wearable, right? And we know regions for creativity that if you have little pulses of magnetism while you're writing, you become more creative. Your thoughts are more creative.
When I
That's
when
just,
I
like, not
meditate,
fair.
not chill, bro. It relates to this, bro. I'm not like the Buddha, bro. Like, I have experiences. Like, so when I meditate,
How often do you meditate, Mark?
like an hour a day, just a big chunk of my time.
That's awesome.
Yeah.
That's a lot
When I
of
meditate,
LSD.
I actually, after I
How much does
meditate,
it
I feel a
cost
lot
to
more creative,
meditate?
Yeah.
and like everything just like when I write or when I like maybe doodle, like everything
Sure.
just connects more.
Yeah.
I don't know if it
Interesting.
relates to that, but
For sure.
Yeah.
Right. You're changing the way
I'm adding
your
synapses.
brain
Right.
is functioning, right?
Right.
You're increasing different areas, you're lowering other areas, right? And so, those experiences can have huge impacts.
I'll ask
Do you
one
have any-
last question.
you have
One last question, and then we can wrap up. So I don't know how much you know about this. This could be like a shot in the dark, but like the AI stuff that's happening is like crazy advanced now. And Sam Altman's saying like, "Oh, we're gonna have AGI by the end of this year," or some crazy
AGI?
predictions. Like it's
Mhm.
where like the AI becomes as smart as humans, and at least on certain levels or something like that.
General intelligence.
Is it not already like smarter?
No.
It's more knowledgeable. It's not necessarily like
Like it can do things that we can't do already, right?
Sure.
Well, a lot of things can do.
But
what
we can do a
can't
lot of things that
Yeah.
AI can't do, right? So
Like yeah.
we can walk around pretty easily, right?
Yeah.
We can.
Oh, it means like that, like becoming
No,
human.
well, no. Just
we
like
we can move from chess to whatever, right? I mean, we have way more ability
Yeah.
than an AI right now.
So I was wondering, like, a lot of the AI stuff is kind of inspired by like the brain networks, and,
Sure.
like neural networks and stuff like that. I just wanted to know what your take on it was, because like the brain is super complex. Is there any way that an AI could kind of duplicate that, or even become more advanced than that, at least anytime in the near future?
Yeah. So my knowledge about how AI works is at a really basic level, right? But here's what I understand. One of the huge breakthroughs in artificial intelligence was trying to mimic the human brain, right? So you have neurons, which are the basic unit of the brain, and you have these things called perceptrons, right? Which were mathematical units trying to replicate a neuron, right? The little units. And so they didn't get very far with this perceptron thing, right? It could do some cool things, right? But it couldn't do a whole lot of cool things. And as we learn more about the brain, the way the brain actually works a lot through what's called top-down processing, right? So my experiences influence my perceptions, right? Or my sensory things, right? So my perception is very much influenced on what I expect to happen, right? That's why illusions get us and things like that, right? And so there's a lot of circuitry that happens in the brain, back and forth, right? And so what artificial intelligence did is like, all right, let's try to replicate that the best we can, right? So let's make these pathways overlapping, right? In sort of this pancake sort of fashion, right? It's called deep learning, right, for artificial intelligence. One of the things that ChatGPT and all these other AI systems are using is what's called deep learning. And really that's about trying to make this more and more complex and intermeshed with each other so the computer can actually learn itself, right? Because the thing that I do can influence the pathways, right? So I become better and better at it. And so what's going to end up happening is, there's going to be computers within our lifetime that I think are, this is my guess, that are going to be smarter than humans. We're going to have AGI for sure. And the question is, what happens with that, right? So how do we take advantage of that and make sure that we're not obsolete? Which Sam Altman doesn't think we will be, right? But others are really scared of that.
Says the tech billionaire,
right?
Who doesn't have financial problems.
I mean, this is like his legacy, so of course he's going to keep pushing it forward.
Sure. But it is going to become more and more advanced. So you have big advances in quantum computers. I don't know if you guys know what's happening with quantum computers.
I heard about that,
And so quantum computing is becoming way more sophisticated.
With
right?
like the cold stuff, like
Ian was telling me about
really
this
cold.
before. There's like, you can like change like the
So
numbers.
right now,
like the
the
binary
way-
numbers can
by
change.
making it like super cold.
So the way your
Something
normal
like that.
computer works is you have a coin, heads or tails, right? So you have zeros and ones.
Right.
What a quantum computer can do is you can have all variations between heads and tails, right? All happening at the same time. Mind-blowing stuff. I don't totally get it, right? And so, like an electron, you learned in chemistry, it's both a wave and a particle, right? And we don't know where the particle is at any given time the way we measure it, right?
But you know, like the
Like the Schrodinger stuff, right?
Is
the
the
cat,
cat dead?
yeah, the cat. And so these computers are using that, right, to make the processing part of it so much more sophisticated, right? And now you apply that sophistication, that advanced computing into AI, and now that perceptron, which used to be like so much weaker than a neuron, right? Because a neuron could do so much more stuff, right? Now you have a situation where maybe the computer can do way more stuff than the neuron, right? And the circuitry becomes super complex, super fast. We're living in a time where you have this, understanding how to manipulate genes through CRISPR and other more recent technology, knowing more about how to manipulate the body, right? Biotechnology and things like that. And now you have the AI stuff happening, right? And understanding the brain so much more. Things I think are going to move really, really fast within your lifetime for sure.
Yeah.
Probably within my lifetime as well, right?
It's
so
so scary.
That's
we're
why I think
going
like
is interesting.
bioethics and
For
ethical
sure.
It's going
classes
to
are
become
becoming
so
more
important.
important.
This like cross
Yeah.
between the
Oh,
science
yeah.
side of it and the
100%.
humanities side of it.
Yeah.
It's just really scary.
Like
'Cause
ethical, 100%. Like,
Yeah, I
you need,
I
like-
do think that more and more students should be taking like philosophy classes, right? And actually wrestling with, how do we think, right? And how do we make moral decisions and how, right? Because you got to practice that stuff, right? You got to build up that frontal cortex, right? Again, it's like the practicing thing. You guys are going to be dealing with whenever you're leaders of the country, right?
our generation.
How do we? Your generation, maybe not you three in particular, but how are we going to make those decisions? And there's going to be some really hard decisions that are going to be happening really soon, probably even for our current president, right? Around this stuff and what we do right now, I think is going to have a big impact on the future of all of humanity, of course.
Bro, it
so
sucks to be
scary.
born in this generation, bro.
No. This is. I
It's
feel like
exciting.
this is like the best
Nah,
generation to be
it's-
born in.
No,
Nah,
that's what
no,
Ullman
no,
said. Ullman was like, y'all win, bro. Y'all win for being born right now.
Well, yeah, but Ullman's also like
Huge,
he's like
huge
the one.
potential is what I would
Yeah.
say.
Huge
I don't know.
potential.
It's just like, you know,
Go promote
everybody's
it.
like there's something super uniquely human about humans, right? But going back to what we were saying earlier, like, it's one argument is that it's all contained within, you know, this complexities within the brain, and if the AI can become more advanced than that, then like it does kind of feel like humans become. I was talking to Ian about this earlier, like a second rung species, I guess, compared to the AI. So
But the AI could make our lives so much better.
exactly. So if we can harness it in the right ways,
So
then-
we could take that AI and figure out climate change,
Yeah.
right?
Yeah.
Now, and how to live in a world that isn't polluting,
Yeah.
right?
Mhm.
How
Yeah.
how that we're not using water bottles, right? How exciting, right? I mean, it could be utopia. I mean,
Yeah,
we
like
really
live
could be on the
longer or
verge of
like-
utopia, or could be on the verge
Destruction.
of dystopia, right? I
Yeah.
mean,
yeah.
we're writing the novel right now.
I mean,
Yeah,
I feel like it's
it's
kind of
great.
similar to how we think about like other like a dog, right? Like I feel
Yeah,
like there are a lot of
yeah,
people
yeah.
out there who like
You're gonna have to explain
no
that.
okay, because
I
you were
get
talking
what
about
you're
like
saying.
second-rate species, right?
Yeah.
And I feel like there are a lot of people out there who like don't consider people like species that aren't humans like second-rate, right? Like maybe not like live next to us, like work in the office.
Well,
next to us,
with
but,
that
you know,
analogy, like I
but
would
not
say,
like-
like humans can control dogs, right? Like,
Like,
humans, like
yeah.
are owners of
they're
dogs.
domesticated.
Dogs
yeah.
don't own humans,
But like a
Yeah.
wild dog, like
so that's
you know.
scary as well because I'm not trying to be owned
By an AI.
by an AI. Yeah.
But some dogs live a pretty
We're
good life.
pets.
It's
right?
like when I'm like 50, like I have
I'm
to
gonna be a
report back
pet.
to like AI 157 like every night.
I have to
Those are
bring
me
him
petting me in my
401k.
sleep, like, bro, get off me, bro.
All right, that seems like a pretty good conclusion.
All right, Dr. Deken, thank you so much for your time. It was a
Absolutely.
wonderful conversation, and
Really interesting. A
Right,
lot
yeah.
of good points and
Yeah, definitely
Insights.
we'll need some meditation after this.
Yeah.
and LSD. Don't forget. That's
I hope to
that's
see
for
you
when you're
guys
older.
in bioethics
Oh,
and
yeah.
or neuroscience.
I think I'm definitely going to sign up for
Sometime.
one. But
Yeah.
yeah.
It's good stuff.
Also, if you see a Dr. Deken in the hallway, give him a big hug. So appreciate it. All right, thank you so much. This is Space Podcast.